Hello everyone, welcome to our channel Off Campus. In this channel we are going to check some important multiple choice questions and answers in electromagnetic field theory in magnetic circuit. Okay, let's start. First question, wait, okay. An air gap usually inserted in magnetic circuits to 4 different options are given. Increase a MMF, increase the flux, prevent saturation, none of the above. An air gap is usually inserted in magnetic circuits to prevent saturation. Then question number 2, the relative permeability of a ferromagnetic material. So, the relative permeability of a ferromagnetic material is usually very high, more than 100 or 1000. Option D is the right option. Question number 3, the unit of magnetic flux is, what is the unit of magnetic flux? It is option B, Weber. Okay, option B, Weber is the unit for the magnetic flux. Then 4, permeability in a magnetic circuit corresponds to dash in an electric circuit. In magnetic, what is analogous to permeability is analogous to what? In conductivity in electrical circuit. Permeability in magnetic circuit is equivalent term is conductivity in electric circuit. Option C is the right option. Okay. Then question number 5, we need to point out the wrong statement. We need to identify the wrong statement from the given options. What is the question? Magnetic leakage is undesirable in electric machines because lowers their power efficiency, increases their cost of manufacture, leads to their increased weight, produces fringing. So, magnetic leakage is undesirable in electric machines because it lowers their power efficiency is the wrong statement. Okay. So, option A is the right option. So, question number 6, relative permeability of a vacuum is, what is the relative permeability of a vacuum is nothing but option A 1. 7, permanent magnets are normally made of alnico-alloys, aluminum, cast iron, rough ions. Which one? Permanent magnets are normally made of, option A alnico-alloys is the right option. Then one problem, energy stored by a coil is doubled when its current is increased by how much percentage? We need to find out the percentage of the current value, increased percentage of the current value when an energy stored by a coil is doubled. We will see. So, this is the energy, and what is the energy stored in the coil is nothing but E equal to half Li squared. What is the energy stored in the coil is nothing but E equal to half Li squared. What is given? Energy stored by a coil is doubled. What is given in the question? Energy stored by the coil is doubled. See this one, double. What is the current value? See, double means it is multiplied by 2 on both sides. So, 2 into half Li squared. So, half into L, keep L as it is I squared now. So, how can we write this squared, this 2 as square root of 2 into I the whole squared, right? It will give the same way, square root of 2 the whole squared will be 2 only. So, we can rewrite as half L into I into square root of 2 the whole squared. Okay. Hence, see, change in the current is nothing but, so before what is the current? Current is nothing but I. Now, square root of I. So, change in current is nothing but square root of I minus I. So, square root of 2 the value is 1.414 minus 1. Okay. So, this is the change in the current, del I equal to square root of I. See here, square root of I minus I. So, square root of value is 1.414 minus 1 I value. So, 1 minus we will get 0.414. So, we need to give the percentage. So, we multiply by 100 we will get 41.4 percentage. So, option C is the right option, 41.4 percentage is the right option. We will see same thing here, del I is nothing but square root of change in the current. So, del I into 100. So, 41.4 percentage is the right option, option C. So, whenever the energy stored by the coil is double, when its current is increased by and option C 41.4 percentage. 9. Those magnetic materials are best suited for making armature and transformer cores which have dash permeability and dash hysteresis loss. See, magnetic materials are best suited for armature and transformer cores which have high permeability and low hysteresis loss. Permeability should be high and hysteresis loss should be low. So, high comma low, option C is the right option. Then question number 10. The rate of rise of current through an inductive coil is maximum. 4 different options are given. So, when the rate of rise of current through an inductive coil is maximum is nothing but at the start of the current flow. Option B, at the start of the current flow is the correct option. 11. When both the inductance and the resistance of a coil are doubled, the value of 4 different options are given. It is related to time constant, here also time constant, initial rise of current and final steady current. We will see, options are given in time constant. No, so what is the time constant? Whenever related to inductance and capacitance is nothing but time constant tau equal to L by R. Okay. So, whenever what is given, when both the inductance and resistance of a coil is doubled. So, both are getting double means 2L by divided by 2R, we will get the same time constant as L by R. So, when both the inductance and resistance of a coil are double, the value of time constant remains unchanged. Option A, unchanged is the time constant, remains unchanged is the right option. Then move on to the next question. The initial rate of rise of current through a coil of inductance 10 Henry when suddenly connected to a DC supply of 200 volt is dash volt second. So, we need to find out the rate of rise of current. We nothing but what is given, inductance value and the voltage given. What is the relation? V equal to L di by dt. We need to find out the initial rate of rise of current means we need to find out the di by dt value. Di by dt nothing but V by L. So, what is the V value? 200 volt divided by what is the L? 10. 200 divided by 10, 20 volts into second is nothing but which one? Option B, 20 is the right option. 13. A material for good magnetic memory should have. A material for good magnetic memory should have low hysteresis loss, high permeability, low retentivity, high retentivity. A material for good magnetic memory should have option D, high retentivity. Question number 14. Conductivity is analogous to, what is the conductivity is related to retentivity, resistivity, permeability, inductance. Conductivity is analogous to option C, permeability. Then 15. In a magnetic material, hysteresis loss takes place primarily due to rapid reversal of its magnetization, flux density lagging behind magnetizing force, molecular friction at high retentivity. So, in a magnetic material, hysteresis loss takes place primarily due to option D, high retentivity. Okay. Then 16. Those materials are well suited for making permanent magnets which have dash retentivity and dash coercivity. Is nothing but those materials are well suited for making permanent magnets should be high retentivity and high coercivity force. Both should be high. Okay. Option B is the right option. Then 17. If the area of hysteresis loop of a material is large, the hysteresis loss in this material will be large also. If the area of hysteresis loop of a hysteresis loop is large means the hysteresis loss also large. So, option B, large is the right option. 18. Hot steel is suitable for making permanent magnets because it has good residual magnetism, it has hysteresis loop, has large area, its mechanical strength is high, its mechanical strength is low. What is given? Hot steel is suitable for making permanent magnets because it has good residual magnetism. Okay, option A, it has good residual magnetism is the right option. 19. Silicon steel is used in electrical machines because it has 4 different options are given. Silicon steel is used in electrical machines because it has low coercivity, low retentivity, low hysteresis loss, high coercivity. Option C, low hysteresis loss. So, silicon steel is used in electrical machines because it has low hysteresis loss. Then question number 20. Conductance, the same thing. No? Conductance is analogous to permeance. Option A, permeance is the right option. 21. The property of a material which opposes the creation of magnetic flux is known as, again, the property of a material which opposes the creation of magnetic flux it is known as reluctivity, magnetomotive force, permeance, reluctance, which opposes means option D, reluctance is the right option. Unit of retentivity is option B, Weber per square meter. What is the unit of retentivity? Is nothing but Weber per square meter. Question number 23. Reciprocal of reluctance. Reluctance is nothing but opposes the creation of, see what is the opposes the creation of the magnetic flux is nothing but reluctance. Okay. Here what is given? Reciprocal of reluctance. Reciprocal of reluctance, what is the option? Reluctivity, permeance, permeability, susceptibility. So, reciprocal of reluctance is nothing but option B, permeance. Here permeability and permeance are given, but reciprocal of reluctance is option B, permeance is the right option. Okay. Then question number 24. While comparing magnetic and electric circuits, the flux of a magnetic circuit is compared with which parameter of electrical circuit? So, which means when we comparing magnetic and electric circuit, the flux in the magnetic circuit is compared with the which parameter in the electrical circuit is nothing but current. Current in electrical circuit is related to compared with which one? Flux in the magnetic circuit. So, from the question, flux in the magnetic circuit is related to the current in the electric circuit. So, option B is the right option for this question. See, option B, 4 different options are given. In that option B, current is the right option. Okay. Sorry for the interrupt. Okay. Sorry. Then question number 25. The unit of reluctance is 1 by Henry or Henry power minus 1. The unit of reluctance is 1 by Henry or Henry power minus 1. Okay. Then 26. A ferrite core has lead eddy current loss than an iron core because a ferrite core has less eddy current loss than an iron core because 4 different options are given. Which one is the correct? Ferrites have high hysteresis. So, ferrites have high hysteresis. So, the ferrite core has less eddy current loss. Okay. Option D, ferrites have high hysteresis is the right option. Then move on to the question number 27. Hysteresis loss least depends on volume of material, frequency, Steinmetz coefficient of material, ambient temperature. So, option D, ambient temperature. Hysteresis loss least depends on ambient temperature. Option D, ambient temperature is the right option. Then question number 28, and this is the last question in this topic. Laminated cores in electrical machines are used to reduce. Option B, eddy current loss is the right option. Option B, eddy current loss is the right option. So, we have seen almost 30 multiple choice frequently asked MCQs in this topic, which magnetic circuit. So, thanks for watching. Like, share and subscribe.